Hello everyone, and welcome to this next video in the Foundation module. In this video, we are going to continue where we left off last time, and we will start building the actual control system for the elevators and the staircases, and then we are going to bring this all into Unreal. Okay, so at this point we have our grid. If we try and scale it, it will work and it will stay inside of our shape, so that's good. We can also offset it, and that's working as well. And finally, we have our points, which describe the center of each grid, and they also work, of course, if we change our values. So all's good there. Now let's have a look at what we want to do next. Over here in the example file, I have a slightly different setup than what we have here, but I'll explain in a second why. It's not a big deal. Basically, what I want to work on next is grab our grid here and turn this into a couple of polylines so that later we can turn this into a visualizer for the top of our building. So this will allow us to see the different grids that we're going to build the elevator and staircase in. And then next, we are going to take these outer lines and we're going to turn them into a series of points. And these points are going to be the points that our elevators and staircases are going to look at in order to determine which way they actually need to face. So let's say I have my staircase point over here. Now at this moment it is a little bit up in the sky, so just to make it clearer, I'm going to snap this one to the grid. It's not necessary for our vex code, but just right now, let's flatten this down to 0. Now what we're going to do is we're going to write a little vex script over here that will find the nearest point on our first input, that being the center of our grid, and it's going to snap that point to that. So this point here is going to snap to that center point. Then next we are going to look at the second point here on the right, and based on its original position, it's going to find the nearest point, in this case that being this one. Let me just template that. And it's going to start aiming at that after it's been moved to the center location. So it will get a normal pointing this way towards the nearest edge. Now we'll look that over inside the code in a minute, but in case you're wondering why I have a couple of extra nodes in here, that's because we don't actually need them, not with the way how I ended up building this system here. And that's simply because in the original project I had used the boolean node in union mode, and this actually kept a lot of the outside grids intact as well. And because those are still the full size, they weren't being called out. So I still had to go and actually select those, or at least select their center points, detect if they were inside of my building shape, and then blast them away. And then from that I could recreate my grid. Now I'm not going to go that deep this time because I don't have to. I actually found a better way by simply setting the boolean node to intersect mode instead. Sometimes you have little oversights or you come up on a better solution in the middle of whatever you're doing, and that's just par for the course. Okay, you are going to find better solutions as you build your tools. Sometimes you're like, why didn't I think of that earlier? This is one of such cases. So let's go ahead and create the snapping system. Let's create a convert line node. Plug that in. And then next, let's grab our create center point node here on the right. Copy that. And let's plug that in below. So there we go. Now we have our snapping targets. Let's move these nodes over here a little bit down to there. And since I don't need this second center point here, let's just get rid of this one. Keep our extract centroid. So we'll start working with that next. Okay, so we have our extract centroid here for the centers, and we have our snapping points here. Next, let's go ahead and create a curve as our input. So this is going to simulate our current input, right? We'll build the actual input setup over here in a minute. Let's create a point somewhere. So let's say over here. And then what I want to do is go ahead and create an attribute wrangle. So this is going to be the wrangle that will snap our points to our various other points. Let's go up here, grab our extract centroid, drag a line down. I'm going to press Alt, create a dot, and then plug it into the first, or rather the second input on our wrangle node. Then let's grab the create center points here on the right, and then plug that into the third input, like so. Let's call this node the Orient and Snap elevators. And we'll do the staircase one after that. And inside this node, let's first create a new vector local variable for the point position. So let's say vector original position equals current point position, and then let's go to the next line. So this will simply grab our current point position of the point we are currently running over, and it will store it as this local variable. Then let's create another local variable called position. Okay. And this one is going to grab the point position of the nearest centroid point. So for that we can use a point vex expression and a near point expression. Now the near point expression, which is written like this, basically requires us to specify which geometry input we are trying to grab our nearest point from. In this case that would be input 1, right? That's the second input here, input 0, input 1, and input 2, right? So the centroids. And then I want to reference this from the current point position itself, so v at p. So based on where this curve point is located, it's going to look at the nearest point in the first input, this one, which would be this one over here, and it's going to return its point number. Now with that point number, we can then go ahead and retrieve the point position on that point. So to do that, let's type a point vex expression. This one's a little bit similar to the one that we can write in vex, except we don't need to provide a fourth argument here. So we can simply say we want to reference it from the input 1 on the node. Again, it's the one that leads to the centroid. Then we want to grab the point position attribute. And lastly, we provide the point number that we want to sample. So in this case, that's going to be the point number of the point that is nearest, right? So the near point expression is going to return the nearest point number on this geometry to this point. And then we're going to feed that to the point expression to grab the point position. This now means that we now actually have our point position for the nearest point stored in this local variable. Let's go ahead and write this out to our point position itself. So let's type v at p equals position. And there we go. Now our point has snapped to whatever was closest over here. Okay, so that's the first part of our script done. And I'm just going to add a little comment to this and say snap to center point in input 1. And then I'm just going to grab everything and scoot it over one tab. Okay. Then the next section here is going to be snap to nearest edge point in input 2. Okay, so that's what we want to do. We basically want to grab from our original curve point the nearest neighbor. Now it's going to get a little confusing here because we can't see it all at the same time. So let me just quickly grab a merge node and plug these two together. So now we can actually see what we're doing. Now after this node, of course, our point has been snapped to the very center of this grid. So that makes it a little hard to determine which of these edge points is actually the closest. But we did actually store our original point position here as a vector local attribute. And we can use that instead of our point position inside of a near point expression to find which point on the edge is actually the closest. So it would basically be very much like as if we had it plugged in like so, right? And in this case, it's easy. This point has this point as its nearest neighbor. Okay, so let's work on the orientation system next. Let's grab this part, copy it, and then paste it down below. Now I do want to write this to a new variable, so let's call this one snap position. And over in the script, I need to change my current input reference to 2. So we are referencing input 2 instead, this one, which leads to our edge points. Then let's also make sure that we change the current position we're checking from, because like I said, we have basically changed the point position of our point. It's now sitting in the middle between all of these. And if we are going to try and reference the nearest point from that, well, it's basically a toss-up on whichever one it's going to grab. Okay, so let's grab the current curve point where that one was located, and that means we grab the original position. Let's replace that one here instead. Okay, so with that, what we've basically done is we are now returning the point position of our snap point, which should be this one. Now next, I want to return a vector from our current point to that edge point. And basically, if we talk about vector math, so let me explain how vectors work, right? So let's say we have a point. And this one's located at the center of our grid. So let's say this one's at x0 and z0. Or maybe for simplicity in this case, let's just use x and y, right? So x and y0. Then we have another point located here. This one's our second point that we're trying to aim towards. And this one's going to be at x2 and y0. Okay, so let's say we want to aim a vector from one point to the other. Well, we could say, let's take this point and subtract it from that point. Well, if we take point 1 at x0 and we subtract 2 from it, we're basically going to get a point over here, right? So this would be x equals -2. And because y was 0 on both, it's not going to change in height. So it basically gets moved over here. And that's exactly what a vector is. It's a displacement from one location to another based on a difference in coordinates. Okay? Now let's reverse this little equation around. Instead of taking point 2 here and subtracting that from point 1, let's do the reverse and subtract point 1 from point 2. Well, if we take 2 and if we subtract 0, we are just going to get a vector like this. So that's exactly what we need to do here. We need to take our outside point, which is this point over here, take our current point, and then simply take that coordinate and subtract that coordinate from it. So that would be the exterior point, the edge point, minus the center point position. So over here inside of our script, let's do that. Let's say our current vector, let's write this to the actual normal attribute, v at n, is the current snap position minus the current position in the center of our tile. And if we do that, it will return a normal. Now right now this normal is a little small, so I'm going to press the D key, go to guides, and I'm going to boost up my normal scale. And if I set this to 1, you'll see that it's exactly the length from the center of our tile to the edge. So that's how you can set up a normal, right? Now I do want to make this a normalized value. So let's go ahead and wrap this inside of a normalize expression. And this will make sure that this particular vector is exactly 1 unit in length. In fact, down here you can see it in the attributes as well. If I disable my normalized value, it returns -2, which is half a tile size, of course. If I enable it again, it's a value of 1, or -1 in this case. Okay, so with that, we have our basic snapping system ready. And now all we still have to do is add the basic input system and copy our boxes onto it so we can have an elevator and a staircase for our building. Okay, so with that script set up, let's go ahead and test it out. Let's grab our curve here, and if I grab the green handle, which is the horizontal move handle, I can move it around, and you can see how our normal and our point are aiming and snapping towards the nearest edge. So that's good, that's all working. And with that we have the main snapping and aiming system completed. So that's the main logic for our inputs complete. But of course we still don't actually have our inputs, and this won't work in Unreal until we do. So let's do that next. Let's go ahead and create a new object merge here. And just like before, up here, let's create a input curve controller. Now in this case, I'm going to call this one elevator point input. And let's color this blue because it's an input after all. And then next, let's go ahead and copy this curve node here, and I'm going to drop it outside of my network, right? So let's copy it, go outside the tool, and then here let's create a new geometry container, and I'm going to call this one the elevator curve, or elevator curve input. Then inside of that node, inside of that geometry container, I'm just going to drop my curve object right there. So I know this point is already in a good position. Let's go back out, and then back inside of our main tool. Now let's grab this object merge and let's promote it to the top level of our tool, just like how we did before. Let's go into the type properties, and I'm just going to drag everything over here a little bit. And down below in our setup folder, I want to add a new entry for this. So let's grab our collision here, let's move it up. And I also want to grab a separator, move that in between. And let's grab another one and move it below that. So we have our collision mode, our building input curve and then 2 separators between that. Let's apply that, and it will look somewhat like this. Then next, let's go to our elevator point input, grab its object path, and plug that into our setup here. Now, as for the name of this parameter, let's call this the curve input elevator. So similar to what we did before over here. And as for the name, let's call this the elevator point input. All right. Now I'm not going to set any default values, so that's fine. Let's just go ahead and apply this. And then we can go ahead and reference our external elevator curve input point right there. So grab that one, set the elevator curve input point, and accept that. And this should already work, right? So now inside of our network, we now have our point being brought into our tool. So we could already go ahead and plug this in, but there's a couple of things we need to do in order to make this work properly. One, the moment we provide a curve inside of Unreal, that curve will always have at least 2 points. And I don't actually want the first point on this curve to do anything, because that would mean that if we did make it do something, we would always have 2 elevators or 2 staircases. I don't want that. So because we always have 2 points at least, I'm going to disable the first point. Now that's very simple. We just need to grab a blast node. And I'm going to call this one remove point 0 for Unreal. And then up here, I'm going to select point 0, make sure it's at the points, and I'm going to color this red. Now, of course, because we only had 1 point, we no longer have a point to work with. So I'm going to quickly go outside, go to my curve, and I'm just going to add another point over here by holding Shift. And I can select another location. Let's go back out. And now we do have another point being created right there. So we had 2 points and we removed 1 of them. Now, if we want to make sure that no matter what we have, we only have points, we can go ahead and create a delete node. Let's plug that in. And the delete node is a slightly heavier form of the blast node. It has more options for deletion. In some ways, it actually doubles as a group node as well. Like, it has similar selection features as the group node has, such as normal and bounding volume. But it also has the ability to keep only your points when you're deleting your primitives. So in this case, if I were to disable this blast node and have my primitive line over here, then I can turn on keep points and simply select every single primitive from a pattern field using an asterisk symbol. And this will basically delete the primitives, but keep the points, right? Very straightforward. So let's call this one keep points. Now there's another way how we can extract the points from a primitive, and that's using an add node. There's a very quick and easy way to do this, and that's by creating a extract all points node. And this one is basically an add node. So the add node normally creates points, but in this case it's been preset to always delete points. So instead of adding a new point, we don't add new points, we simply delete all the geometry but keep the points. So same story, different node. Okay. Now, in our case, we can keep either one. I'm going to keep the second one here, extract all points. And next, let's plug this in over there. Okay, so we now have something that will work for Unreal. Okay, so we have an input. We can control it from the outside of our system. And even if Unreal will always provide us 2 points, we have a filter for that, so that will work. Now at this point, before I go and add the second version of the input system, let's go ahead and actually make this all work so we can see it inside the Unreal Engine, because we've worked with theory and math and everything for far too long at this point. So let's go ahead and pull a line from this node, and I'm going to pull it down here, down below. Let's add a dot, and then I'm going to add a net box right here. And this net box is going to be for our elevator shapes. Now with this, let's go ahead and create a box object. That's going to be the basic shape of our elevator. I'm going to give this box object the size that our grid here has, so 1 grid square. So we can grab our parameter panel, grab the elevator and staircases tab, and then from the interior grid scale, let's copy this, go to our box, which we'll call the elevator shaft shape. And inside of our parameters, I'm going to paste the grid scale in the X and Z channel. So now it should be the size of our grids. Next to this, I want to give it some height. So let's have a look at our building over here on the left. We have our copy to floors node over here, which describes the exact height of our building. Right? So we currently have the bottom floor and the top floor. So if I go ahead and reference this node, let's go to the elevator shaft here, go to size, and then say bounding box dot slash copy floors 1. This will reference that node over here. Then inside, as the second argument, let's grab dimension underscore y size. And this, just like before, will simply grab the size of that bounding box, right, of our building, no matter what size it is. Now if I go ahead and look at that, we can see that it has the same size, but it isn't quite offset right. So let's copy the size in Y on our elevator shaft shape, paste it into our center as a relative reference, and then multiply that by 0.5. Okay, so now our elevator shaft has at least that minimum shape. Next, what I would like to do is take the door height for the elevator, the top floor, and add that one on top as well. So let's go ahead and grab that. We should have it up here in the doors and windows tab. I'm going to add this to the end of it. That will mean that we'll have at least one door height worth of space up here. Then next, let's also grab the frame thickness, because I want to add a little bit of frame above our door, right? Just like we had with our tiles. We have our door frame, and we at least have our frame thickness above it, above our door. So let's grab that, copy this. Let's add this to the expression as well. And if your expression gets a little too big, you have two options, of course. You can either expand your parameter window as big as it gets, or you can press Alt-E, and this will open up the expression editor. Now it's a bit tricky to paste expression into here. You can't actually do that, so you would have to type them out, or alternatively paste them in here and then open this back up. But it does allow you to have a bigger overview of what you're typing. Now the last part I want to add is the floor depth for the roof of our elevator. So let's just grab this, and in this case I'm just going to type it out actually. Let's say plus channel reference // and then floor depth. And we do get this drop down here for the parameters, so we can use this. Okay, so with that, let's go ahead and accept that. And this should now give us a elevator shaft that's exactly the size of the building that we want to create. Okay, cool. So we now have that. Let's go ahead and copy this onto our point. So just like before, when we copied our tiles, we just need a normal at the very least. And if we grab a copy to points node, we can grab this box and then plug it in here like so. And this should now place the box onto our point, aiming in the direction of the normal, right? So here's the point, there's the normal, and here's the box. Next, let's go ahead and add a null node behind this. And I'm going to call this one out elevator shaft. And let's color this one gray, because it's going to be a node that I'm going to object merge over here to the left. Okay, so that is the basic elevator shaft done. Now let's go ahead and copy this for our staircases as well. So what I want to do here is grab these nodes, all of this, and move it over to the left. And then I'm going to copy this section over here, paste it in. Let's get rid of that, by the way. And I'm going to rename this to staircase points, or staircase point input rather. Also, let's rename this wrangle node to staircase. Then let's go ahead and plug this up to our interface as well. So I'm going to actually change the name up here to staircase. And of course this one doesn't exist, so it's looking for a reference that it can't find. It's not going to throw us an error, but it will be a problem. So let's go ahead to the type properties. And down below, I'm simply going to copy this part, paste it, and I'm going to change the name by hand. Now the moment we create this link, like so, and we accept that, then now this reference should work. So let's go ahead and test that out. Up top, let's copy the elevator curve input. Let's name this the staircase curve input. And with this curve, I'm going to grab its second point and just move this one over somewhere else inside of our building. Then now, let's go ahead and open up our parameter panel. And we need to, of course, reference this staircase curve as well, or we won't actually get it. Grab that, select the staircase input right here, reference it, and accept. So with that, our object merge, our new one, is now actually grabbing our curve. So as you can see, we have our staircase curve. We're extracting a single point from it. And then our snapping code down here is basically doing the same thing as what the other one did before. It's simply snapping it towards whatever grid point is closest. So that's cool, right? So let's do the same thing down here. Let's grab this network, copy this over to the right, and let's plug it in. So we are using our staircase point. I'm just gonna rename these as well. It's gonna be our staircase shape. And then our box here, let's call this one the staircase shaft shape, or staircase shape. All right. And as for this one, let's rename this to staircase shaft. Sure. Okay, that's good. We now have this, but the staircases in our tool are slightly longer or differently shaped. So over in our elevator and staircases setup, I'm going to add some new parameters here. Let's go to the type properties. And what I would like to do is add a new integer attribute right here under elevators and staircases. I'm just going to add a separator in between as well. Now this first integer I'm going to call stairs width. And as for its label, I'm going to call it the stairwell width in units. So basically our grid units, right? So the amount of width, if it is 2 units wide, it's 2 grid units wide. Now, as for its default values, I'm going to lock it at least 1, so it cannot be less than 1, obviously. And for its default value, it's going to be 1 as well. Then let's copy this, paste it, and I'm going to call this one depth. This is going to be the stairwell depth in units. Now, at this moment, our grids, our staircase system, is only going to work with depth of at least 2. So I'm going to lock this at 2. But later on in the masterclass, when we are working with the Ascension module, the second module of the masterclass, we will actually have stairs that create spiral staircases that can work in a 1x1 square area. Okay. So for now, I'm going to set it to 2. At a default of 2, and I'm going to accept that. Okay, so with that, we now have the ability to configure the size of our stairwell. So let's do that next. Open up the parameters panel over here. And as for the code, let's go ahead and take the size X for our grid scale. And I'm going to multiply that by the stair depth. Let's copy this. Multiply this. And this will make the stairs wider. But it's also aiming in the wrong direction, because right now this staircase is actually pointing this way, right? Straight down this way. And that's not the depth of the staircase, that's the width of the staircase. So I am going to take my cube here and I'm going to rotate it by 90 degrees. We're just going to grab a transform node here, plug it in behind, and I'll say rotate staircase shape. So let's rotate this thing 90 degrees. And now it should be aiming in the correct orientation. Okay. Then next, let's do the same thing for the Z channel. Let's grab the staircase width. Let's multiply that. And now this should at least allow us to control the width and depth of our staircase. Now at this point, this staircase is actually offset. And you can see that it's not aligning with our grid, right? So if I scale it up, it might look like it, but it's actually scaling from its center point. And what I would like to do, and this also applies to its width as well, is to make it so it sits right on its own corner and it will still align with the rest of the grid. So to do that, we need to offset it, and we need to offset it so it always has its corner as the main center of this cube. Now later on, I'm going to use a wrangle node to actually move the spawn point here back and sideways so it works for every single element. But for now, I'm simply going to fix it over here inside of my cube here, and we'll fix this later. So let's create a transform node, and I'll show you how this is going to work. So this is going to be the temporary offset. Okay. And let's go ahead and grab my drawing board. And I'm going to draw a very simple cube, which represents our staircase, right? Now this staircase is going to be 2 by 2. So let's just cut it down the middle. And right now, it basically has its center point right there. Now what I want to do is move it over here. To do that, I can simply grab its width and its height, take half of that, and then move my center point to this corner here. Okay, so we'll first move it to the far corner of the building, of the staircase. And then we move it back by half a grid unit in both the depth and the width. So it will eventually end up in the corner, no matter how wide this building is actually going to get. So even if this building gets really wide, like this, and the center point used to be over here, it's not going to matter. It will always be over there because we moved it here first and then in that corner. Okay, so let's go ahead and do that. Over here on my copy the points node, I have my box on top of my spawn point, which is located right there, aiming inward. And then here, I have my box, which is 4 units wide and 2 units deep. Let's make that 3 units deep for now. So for our offset, that would mean we need to offset our box sideways, which should be the Z channel. Yes, we need to offset this sideways by 8 units. Okay, so that would be to bring it on top of that point right there, where our center is. And then we need to reduce this again by half the grid size, so that's -2. And then for the X channel, let's go ahead and move this up so it sits on top of that corner, which will be a value of 6, because that's 3 times 4 divided by 2 is 6. And then we say -2 as well. So that's what we got to do, right? Now to do this, to accomplish this, we can simply grab the interior grid scale, copy that, paste it in here. Let's expand this a little bit. Then let's multiply this by the stair depth, because this is the depth value right there. So copy that, paste it in here. and then I want to multiply that by 0.5. Okay, so now it's sitting on that corner over there. Then next, let's make sure that it offsets it back by half a grid size. So I'm going to wrap this inside of a bracket, and then I'm going to say minus the interior grid scale and I'm going to wrap this inside brackets and say multiply that by 0.5 as well. Okay, so now it's sitting on that corner. Let's copy this script and then paste it over here to the right inside of our Z channel. And I gotta make sure that the stair depth becomes stair width. So with that, if we now scale our stairwell width, see how it's moving sideways, okay? But it's not moving from its center, it's moving from the corner. And likewise, depth-wise, it's also fixed. So no matter the orientation of our staircase, it will always be located aiming forward from this point there, from its corner, its left bottom corner. Okay, so like I said, this is a temporary node. We are going to remove this one later on, and we are going to move the actual spawn point. But I wanted to keep this simple for now. So let's grab these two, and let's actually integrate these into our building. So I want to create a switch node for each one of these. Let's create a switch. And we're going to replace this one later with the actual staircase model. But for now, let's grab it from our out node here. This is going to be the height elevator. Let's add a null node behind it as well. So in case it's turned on hidden, we're going to use the null node. Otherwise, it's going to use the actual elevator shape in this case for now. Let's go ahead and hook that up to the interface. So let's open up the type properties. And let's grab the value from up here. And let's plug it above into our elevators and staircases tab. So I'm going to call this a height elevator toggle. And by default, I'm going to make sure it's turned off. I don't want to always hide my elevators. Then let's copy this. And let's rename this one to height staircase. Also, default value is 0. And let's add a separator in there as well. Okay, so let's accept that. Now, let's copy this network, plug it in over here, and let's rename this to hide staircases. Now, as for its reference up here, we do need to change this as well. So let's change this from hide elevator to hide staircase. So now we should be able to toggle this on and off, and the same thing for our elevator. Okay, so let's go ahead and grab these switches and let's plug these into our output over here, into our merge node. So now if we look at the output, we should now have a basic shape for our elevator and our staircase in our building. Now they're too big, so I'm going to just scale them down and maybe move the grid over a little bit. So let's say by 2 units. Okay, so now we have some good shapes in our building. And then last, what I would like to do is take these and punch a hole into the floors of my building, so that's sorted out as well. Because right now, if I hide them, they're basically just boxes in our building that aren't going to do anything yet. So let's grab a object merge. I'm going to call this one in shafts, right? Because they're both elevator and staircase shafts. And I'm just going to grab this node, out elevator shaft, plug it into the first reference. And just to make sure we can see this, I should have turned this on before, but let's show our dependency links. Here you can see we have a link. And then let's grab our staircase shaft as well. Let's plug that in. So here are both. And then I'm going to move it up here to where my floor section is. So next, let's grab this copy floors node, and I'm going to move this up. And actually, what I want to do is grab this triangulate floors node. I'm going to break it off, and behind our copy floors node, let's place a boolean subtract node. So like I showed you before with the boolean nodes, if we grab a shape or multiple shapes like this, and we plug this in, then we can actually take another shape and subtract that from that. And it will simply cut straight through our building, like so. Now, we do need to fix the triangulation, so that's why I moved my triangulate node here. Let's grab this, plug it in, and this will triangulate all of our floors properly, with the holes cut in them as well. Okay, so with that, we've almost finished this. I just want to fix one thing here, and that is that the elevators are being cut out of the bottom floor. I don't want that. So let's go ahead and fix this. Let's zoom out. And out here, I want to add a new transform node in front of my elevator and my staircase. And I simply want to flatten this point on top of the floor. So let's take the scale in Y, let's flatten it, and then let's grab the floor depth. I'm going to put it inside the translate Y channel. So that already fixed the elevator. Let's grab this, copy it over, let's plug it in for the staircase as well. And the reason I'm putting it here is because later on we also need this for the more in-depth part of the code. So instead of fixing it right here, I want to fix it at the source, right there. Alright, so at this point we have our holes cut, we have our elevator shapes added. There's only one more thing that I want to add, and that's simply to support the alternative input method inside Unreal. But before we do that, let's quickly test it out inside the Unreal Engine, okay? So let's go ahead and save the tool. And then in the Unreal Engine, the other one, here we have our asset. Let's say re-import. And then on the tool, we got to click rebuild. So this should already work. And if I look under the setup tab, we now have two new inputs. Now I haven't actually set up the input names to automatically reference a curve, but at this moment that's not a big issue. Let's just go ahead and first expand our building a little bit, so we have a little bit more space to work with. And then let's start first with the elevator points. So over here, I'm going to turn this into curve input. And this will create a curve point down here. Okay. drag it up to the roof. And then I'm going to move it around. So let's find a nice spot for it. Okay. So we don't actually have our grid like we have on this building to visualize where we're working. But for now, that's fine. Then next, let's also add a staircase over here. Let's add a staircase point. All right. Let's move this one somewhere else. So first up to the roof, and then let's move it over. So with that, now I should be able to rotate it as well. So with this, if I move it into a different corner, it will aim in a different direction. Now, like I said, if you force it to, you can make it go outside of the building. That I can't do anything about unless I write specific code to prevent that. But it is working. We can now actually control where the staircase is and where it's aiming. Now there's only one last thing that I want to do before we wrap up this lecture, and that is add the actual object-based input using a cube. So we can add a cube to our building, and then using that we can then control where our elements will spawn. So let's go back to Houdini and let's just do that real quick. So over here, where I have my input curves for the elevator and the staircase, let's grab these two nodes for, say, the staircase, and let's wrap these into a subnet. I'm going to color the subnet dark blue, because this is going to be my input methods for the staircase. Then let's dive in here. And this should already have given us an output node, so that's useful, because it was already hooked into the rest of the network. Then inside of this, I'm going to grab a switch node, plug that in, and I'm going to call this one the input method. Like so. And then next, what I would like to do is grab a null node, add it below my input here, so I have a proper clean input node to grab from. And I will call this one the Unreal Object Input. Now, in case this is actually a mesh, we can take this object and check if it's a single object or if it's two different objects. Now, in order to test this out, I do need to actually go ahead and add some objects into my input. So let's go back to the outside, go to our staircase curve input, and I'm going to create two little boxes here. Something like this should do. And then let's grab a merge node, and I'm going to plug these together. Now, when I created the input setup here for my tool, I explicitly referenced the staircase curve input geometry container, which means that right now, if I go into the tool, it's actually referencing from the object merge my two boxes, or rather whatever is coming out of that particular object container at the time. So we can use this to simply filter out each of these as individual objects and then create a center point inside of them. So let's do that. Let's create a for each by connected piece. If we do this and we plug it in, then this type of for each loop, which we haven't used yet, will take each connected piece or each connected primitive, and if we turn on single pass here and we switch it between 0 and 1, you can see how every single loop here is grabbing one of the two objects. Then next, all we have to do is create a point in the center for this box. So let's create an add node. And the add node, if we just turn one point on, will create a single point currently at our grid center. Okay. Now I want to reference the center point of this box. So let's create a null. Plug that in. And I'm going to call this one, this null node, the Unreal object. Then let's break this link and let's plug in the add node right here. And this one's going to be called the add center point. And let's create a spare input link between these. So I'm just going to go over here to the gear icon, add spare input, and then just reference the Unreal object for that. Okay, so that's created our link. And then inside of the add node, let's go ahead and type centroid -1 d_x. Let's also do the same thing for the Y and Z channel. And with that, depending on where our cubes are located, let's turn on both of them. We now have 2 points, one for each of our cubes. Okay. So with that, we have a basic way to retrieve a point from whatever mesh we feed it. It could be a cube, could be a sphere, it could be a grid, right? It doesn't matter. Whatever mesh we feed it, we'll always get a center point, as long as it's a single mesh. Let's then plug it in. And I would like to promote this to the top level of this particular subnet. So let's open it up in the edit parameter interface. Let's shrink this a little. And then in here, I'm going to grab this switch node and drag over our parameter. So now we have it here. I'm going to hide these labels. And I'm going to set this to an ordered menu. So just like before in the previous lecture, let's switch it over. Let's call this one the input method. Input's fine. And then under the menu tab, let's add the first entry. It's going to be 0, which is going to be our use curve input. And then the second option is going to be a token of 1. And the label is going to say use mesh center. All right, so let's accept this. And now on the outside of this subnet, assuming this is hooked up properly, we now have a switch that can extract either a curve or process our curve if we provide a curve, or we can process a mesh center like so. All right, so with that, let's go ahead and grab this subnet. I'm going to replace these nodes with a copy of that. And let's just name this the input method for the elevators. All right. And now the last thing I need to do, of course, is to take these controls and promote them to the top level. Let's go ahead and grab our type properties next. And let's grab the elevator input method. And let's put it up here in the setup tab, right above our elevator point input. And we'll call this one input method for elevators. Then let's do the same thing for the staircases over here on the right. Drag it down here. Let's call that one the input method staircases. Okay, so if we accept that, then now we have our controls right here on the interface. Now currently it's set to use mesh center as the default. I don't want that. I think I accidentally promoted that up as a default value. So I'm just going to go back, go to the values here, and I'm going to switch this over to a default value of 0. If you select both at the same time, it should do it for both at the same time, right? So with that, we now should have our elevator system working. If we look over here and we make sure we have a proper input, we now have our elevator cube, we have our staircase cube, and we can switch this over to mesh center or curve input, depending on what we're using in Unreal. We can change the shape. And finally, we can go ahead and hide these elements so we only have our holes. And then we can use that later in the later parts of the master class to inject our dedicated elevator and staircase tools. So let's save this up. Save node type. Let's match the definition after we've saved. I'm going to save my scene, and then let's just quickly test it out in Unreal, and then we'll call this a lecture. So over here in Unreal, let's go ahead and re-import our tool. Right click, rebuild. And now under the setup tab, we should now have our input method for the elevators and the staircases. All right, so let's grab the input method for the staircases, and I'm going to switch this over to mesh center. And then as for the actual input method here, I'm going to switch this to world outliner input. And this will allow us to now select our cube as an input source. So in order to do that, we have to click on the Start Selection button, and then we can select our cube. And then we can click Use our current selection to confirm that. And there we go. We now have our elevator, or our staircase rather, being spawned on top of our cube. So I can now move it around. And this will work. However, we still have one issue, and this is actually something I forgot. Let's go back to Houdini. I'm going to open up the tool again, right? And what we need to do is go over to our object merges, these two, and we need to switch them over from transform into specified object into this object. Otherwise, in Unreal, it simply won't know where in world space our tool is located, and then it will just assume it's located at world center. And considering in Unreal right now it is not located at the world center, which is there, it's breaking. Okay, so right now it's assuming our cube is located somewhere over here, which is wrong. So with my object inputs set to into this object, it is going to actually fix our object setup. However, it is going to break our curve inputs instead. And that's because the curve inputs actually do expect into specified object. So what we need to do is set up a little switch in here, an if statement, that is going to toggle between into this object or into specified object, depending on which mode we are using. So if I go ahead and grab my parameter panel, then what I want to do is hook up this switch here to the transform menu right there. And for this we need to write a simple expression. So what we want to do is make sure we have the staircase object merge selected, and then go to our transform parameter and right click it. Then we go to expression and edit the expression. Now at this moment, it simply has the value that's currently set, and that's currently local apparently. So I'm going to remove this, and I'm going to say channel reference .. and then we want to grab our input method for the staircase. So that's going to be input method staircases. And when I plug this in and I click apply, it is going to hook it up. But right now it's hooked it up the wrong way. What we want is, if we have our mesh centers active, we do want into this object, that's fine. But if we switch it to use curve input, we actually wanted to use the default into specified object option. And right now it's going to set it to none, because none is the 0 value and into this object is the first value. So it's not just flipped around, but there's more entries in here. So what I'm going to do is write a little if expression. If the input method for the staircases is equal to 0, so that's our curves, then I want to use entry 2, and otherwise I want to use entry 1. So in effect, what it's going to do is it's going to check if this particular input is at state 0, and if it is, it's going to use value 2, otherwise value 1. Let's accept that, and now, depending on how we flip this, it's going to switch it around to its correct setting. You can already see that it has an effect here on the curve, on the input. So that's good, at least that's the expected behavior, because there's our curve, and before it was actually putting it somewhere else. So now let's copy this expression, click on transform, and then go to copy parameter. Then I'm going to go to the elevator point input here, and I'll go right click, go to paste other, and then I'm going to paste the copied expression. Now we still need to actually change this because it's currently still referencing our staircase. So let's right click that, open back up the expression editor. And then in here I'm going to change this to elevators. So now this should be fixed. If we go back to the end of our network and we save, then let's go back to Unreal, and in here let's reload or re-import the tool, right click, rebuild, and now depending on the mode in which we are using the tool, it should be working. Now there's one thing that needs to be turned on for World Outliner to work, and that is keep world transform. If this is off, it will fail, okay? This needs to be turned on. So let's go in here, grab our cube, and let's move this one around a bit. Okay, so it's working, right? At this point, we have the ability to configure both our staircase, which right now is using a curve input, and we can move this one around, and that works. Okay, and we have our cube, and if we select that, we can move around our staircase as well. Okay, so let's go ahead and test this out. Here we go. Let's go into the building. And here we have our holes. So we can jump into them. We can't quite reach the next level. That's just a little bit too high for our player character to jump. But at least we now have a space for our elevator and our staircases to exist in. We have a way to control where they should be. And in future lectures, we are going to add those as well, so we can actually climb up to the top level. Now, that's not what I'm going to work on in the next lecture though. In the next lecture, I'm actually going to work on the visual elements on this building, so we actually have a better idea on what we're actually doing when we are using the tool. Because right now it's a little hard to actually see where our grid is. So I want to create a grid. I want to add the arrows into the grid that show where our elements are actually supposed to be. And I also want to add the lines on the edges here, which indicate the corners of our building where we remove the tiles. I want to add the numbers to the side of the building so we can designate where the door should go by number. And there's also this line here, which is the seam of the building. And this is basically where the tile circulation, the tile numbering, jumps up one floor. And I want to be able to control that as well. So with that, I think we are about ready to wrap up this lecture video. If you want and you have some progress to show, feel free to come to my Discord channel. I'd love to see what you're up to, what you've made. Otherwise, if you have any comments, go ahead and leave them in the comment section below. I always like to hear what you guys think of these videos. And with that, I'd say thanks for watching and have a good one.